Hello, assalamu alaikum everybody. I hope you are all fine and staying at home. And as you know, that the university has decided to shift to online lectures, and this is our first lecture of signal and system course and fourth in total. And in today's lecture, we are going to discuss about even and odd signals, and we'll be discussing also about periodic and aperiodic signals. This is my email address. You can contact me anytime using this email address regarding queries about this lecture. An even signal is symmetric about the origin. It means if you apply the time reversal property, you will get the same signal. It won't be affected. For example, x of t is a signal which is shown in this figure, and if we apply time reversal property x of minus t, you will get the same signal. So these kind of signals are called even. And on the other hand, the odd signals are anti-symmetric about the vertical axis. For example, x of t is a signal as shown in this figure, this one, and if we apply time reversal property, you will get amplitude reversal in return. These kind of signals are called odd signals, and they are anti-symmetric about their origin. Now this symmetry about the vertical axis is very important in evaluating some complex mathematical operations on signals. Therefore, sometimes we need to find out the signal that we are dealing with is whether it is even signal or odd signal, and once we know it is even or odd signal, we can actually simplify our calculations a lot. For example, while we are calculating or we are actually representing our signal into the Fourier series form, then if the signal is even or odd, then computation becomes a lot more easier. There are some examples of even and odd signals. Can you guess which one is even signal and which one is odd by just looking at the figure? For example, this one, you can see the pattern on the left hand side of the vertical axis and on the right hand side both are same. Even if you apply the time reversal property, you will get exactly the same signal. Therefore, we can say this one is even signal. And similarly, here this signal has the same pattern on the right hand side of the vertical axis and on the left hand side of the vertical axis. Therefore, this is also an even signal. And these now all the signals can be decomposed into even and odd components. So if you want to decompose signal into even and odd components, you can find out using these two simple equations. The even part can be determined using this equation x of et, where e here represents the even part and o here represents the odd part. So x e of t equal to 1 upon t and x of t plus x of minus t. And similarly here, if you find out the difference of x of t and x of minus t and divided it by 2, you will get the odd part. So if you are given a signal x of t, then you need to first find out x of minus t, then find out the sum of these two signals and divide it by 2, you will get the even part, and find the difference of these two signals and divide it by 2, you will get the odd part. Now let's consider this signal and find out the even and odd parts of x of t. Now x of t here is from -1 to 1. First we need to write down the mathematical expression for this signal. You can see from -1 to 0 it is a ramp function of amplitude 2, and from 0 to 1 it is a unit step function, and everywhere else it is 0. So the mathematical expression for this would be x of t equal to 2t plus 1 minus 1 to 0, and from 0 to 1 it is 2, and everywhere else it is 0. So this is the mathematical expression. Now we need to find out the x of minus t. In order to find out the x of minus t, you can multiply t here with minus 1 everywhere. Wherever the t appears, you can multiply it with minus 1. So when you multiply t with minus 1, you will get this expression: x of minus t equal to 2 between minus 1 to 0, and 2 into 1 minus t between 0 and 1, and 0 elsewhere. So you can see the signal is folded around vertical axis. Now you know the value of x of t and x of minus t. Now you need to find out the sum of x of t and x of minus t, and difference of x of t and minus x of t. And when you divide these two with 2, you will get the even and odd parts. So first we will find out the sum of x of t and x of minus t, and then divide it by. So in order to find out the even part, let us find out the sum of x of t and x of minus t. So sum of x of t plus x of minus t would be, first you will sum the components which are between minus 1 and 0. So minus 1 and 0 you have 2t plus 1, here minus 1 and 0 you have 2, right? So 2t plus 1 plus 2, and then add the components between 0 and 1. 0 and 1 you have 2 in x of t, and you have 2 into 1 minus t in x of minus t. So adding these two together, and obviously everywhere else would be 0. Now simplify it further, you will get x of t plus x of minus t, and you have to divide it by 2 as well in order to find out the even part. So after simplifying it further, you will get the even part of the signal. Now can you sketch the graph of the signal? This one is ramp function, and with the offset of 2, and this one is also a ramp function with a negative ramp function with a negative slope. This one is a positive slope ramp function with the offset of 2. So between minus 1 to 0, you will draw a ramp function with the offset of 2, and here between 0 to 1 you will draw a ramp function of a negative slope. It means a decreasing ramp function with the offset of 2. If you draw the graph, you will get this. This is t plus 2, and this is 2 minus t. This is the even part of the given signal, and in the same way we can actually find out signal. In order to find out the odd part, you have to find out the difference of x of t and x of minus t. So the difference of x of t and x of minus t can be determined similarly, just like we find out the sum in the last slide. You have to be careful about the time intervals. You have to add parts. You have to find out the difference of the parts which are in the same time interval. For example, minus 1 to 0. Minus 1 to 0 you have 2t plus 1, and you have minus 1 to 0 you have 2. So 2t plus 1 minus 2, and similarly here 0 to 1 you get 2 minus 2 into 1 minus t and 0. Simplify it further and divide it by 2, you will get the even part of the signal. Again, let us sketch the graph of this function. Now you have two ramp functions, one increasing ramp function, this is a unit ramp function starting from minus 1 to 0, and then another ramp function starting from 0 to 1. So basically you have a ramp function from minus 1 to 0, unit ramp function, and then another ramp function from 0 to 1, and then 0 everywhere else. This is the odd part of this signal. And here is another example as a practice for you. And a signal x of t is given in this figure, and you have to write down the mathematical expression first, and then show that it can be decomposed into the following even and odd parts. This is the even part, and this is the odd part. Find out the mathematical expressions for the signal x of t, and also for x e of t and x o of t. Now the periodic signals. You are already familiar with these kind of signals. Periodic signals are the signals that have some fixed pattern. They repeat themselves after a fixed pattern. A signal is a periodic signal if it completes a pattern within a measurable time frame called a period and repeats that pattern over identical subsequent periods. A formal definition for periodic signals. So if a function g of t, for example, is a periodic signal, then g of t plus t naught would be equal to g of t, where t naught is the time frame after which it repeats itself. Right? So t naught is called the fundamental time period, and it can be measured in seconds, milliseconds, or so it is basically the time. Its unit is second. A period is defined as the amount of time expressed in seconds required to complete one full cycle. A complete cycle of that is called the time period of the system. So any signal that requires time to complete one cycle is called the period of the signal. And obviously the reciprocal of time period is the fundamental frequency, usually represented by f, and it is measured in hertz, cycle per second. You can see in this figure we have a sinusoidal waveform, and we all know that a continuous time sinusoidal waveform is actually periodic waveform. So period of the sine wave can be calculated from one peak to another peak value, that is called one complete cycle, and it is measured in seconds. And reciprocal of this period is called the frequency of the sine wave. These are other examples of periodic waveforms. For example, this one. Can you tell me what is the time period of this waveform? Yes, it completes one cycle and 2 pi seconds. Right? So its time period is 2 pi. And this one is another waveform which look like an ECG signal of a human being, and you can see ECG signal is repeating itself after some fixed time pattern. That fixed time pattern is called the time period of the wave. A signal that doesn't repeat itself after a fixed period of time, that is called aperiodic signal, which is not periodic. Any random signal, for example this one, this is not, there is no fixed pattern, it is randomly changing with respect to time. So these are the examples of aperiodic signals, this one as well and this one as well. So these are called aperiodic signals. And now sometimes what happens that we add or multiply periodic signals together, right? So a common situation in signal and system analysis is to have a signal that is sum of two periodic signals or multiple, more than two, right? Then how to find out the resultant time period, what would be the resultant time period, right? So let us, for that, to establish this, let us consider two periodic signal x1 and x2 with periods t1 and t2. So x1 is, for example, is equal to x1 t plus t1, and x2 is equal to x1 t plus t2, where t1 obviously is the period of x1 and t2 is the period of x2. Now if both signals are added together and the result is x of t, so we can write down this in mathematical expression as this equation. Now if the ratio of time periods, which is t1 upon t2, is a rational number, then x of t is periodic, otherwise not. So when you add two signals together and result you need to find out whether the resultant signal is periodic or not. Find out the ratio of the periods t1 upon t2. If it is a rational number, then the signal is said to be periodic, otherwise. Now there is a simple exercise for you to determine which of these signals are periodic or not. If the signals are periodic, then determine the fundamental period. So the first one, g of t equal to 7 sine 400 pi t. Obviously it is a sine wave, it's a periodic waveform, and can you determine what is the period of the sine wave? In order to determine the periodic of the sine wave, let us compare this sinusoidal function with a general sine wave, and from this comparison you can determine what is the value of f. So f here is 200. So if fundamental frequency is 200, the reciprocal of fundamental frequency is the time period of the wave, which is 1 upon 200. Okay, so now coming to the point, part number C, and part B is left as a homework for you. Give it a try, and if you find any difficulty, you can contact me using my WhatsApp number or the email address which is given in the first slide of this lecture, and I will reply you as soon as possible for me. So in part C, we are given a complex exponential function, and we have to determine whether it is periodic or not. If it is a periodic function, then what is the fundamental period or the fundamental frequency. So we know it is a combination of sine and cosine function, so we can rewrite this complex exponential function using the Euler's formula as this one: g of t equal to cos 60 pi t minus j sin 60 pi t. Now these both the components have the same frequency, which is 30 hertz. So the fundamental frequency of this signal is 30 hertz. It means the fundamental time period would be the reciprocal of 30 hertz, which is 1 upon 30 hertz. So this signal is periodic. Now coming to the fundamental time period equal to 1 upon 30. Part D. In this part, we are given a function g of t, which is the combination of sine and cosine functions of different frequencies, unlike the last example. And the frequency of this component is 6 hertz, and the frequency of this component is 9 hertz. So the corresponding time periods of this component is 1 upon 6 seconds, and time period of this component is 1 upon 9. Now we need to find out whether the resultant function g of t, which is sum of these two components, is periodic or not by finding out the ratio of time periods. So if the ratio is rational, the function would be periodic, otherwise not. So t1 upon t2 is basically 9 upon 6, which is equal to 1.5, which is obviously a rational number. So therefore we can say that g of t is also periodic. Now we need to find out the time period of what is the fundamental period, common time period of the two fundamental frequencies. So fundamental frequencies are 6 and 9, and the greatest common divisor is 3. Therefore the fundamental period of g of t is basically 1 upon 3. So pictorially, this is the first sinusoid having frequency 6 hertz, this is second sinusoid having frequency 9 hertz, and this is the sum of these two having time period 1 upon 3 seconds or frequency 3 hertz. So it repeats itself after each 1 upon 3 seconds. That is end of this lecture number 4. And once again, if you have any queries, you can contact me using my email address, and if you have my WhatsApp number, some of you have my WhatsApp number, so you can contact your colleagues and find out the number and send your queries via WhatsApp or via email, and I will try my best to respond you as soon as possible.